it's been all over the map, but I've gotten involved with the nano side of it, fallen in love with it. You asked me earlier what gets me up in the morning.
Yeah.
It's the possibilities of this science. It's an amazing science.
When we talk about our delivery system, which we always talk about Hydrastat, and we use that as a common theme.
Right.
Why is our delivery system so much better than traditional supplements, but even some other companies' nano supplements or liposomal? I mean, why is ours so bioavailable? How does it get into the cell?
Well, the reality of it is that there's several steps that we go through. And the whole idea, this whole concept, let me back up one quick step, and I'll make this as simple as I possibly can, not because I'm dealing with simple people, but I could spend 3.5 hours on this call telling you about nanotechnology, and I'm sure you don't want to have that. That would be the one that you'd listen to just as you fell asleep in the first 10 minutes. Anyway, but now when you start talking about nanotechnology, it's anything under 100 nanometers. It's manipulating particles and other things under 100 nanometers. Now, a nanometer. If you were to take a meter stick, for those of you all around the world except for the US, and in the US you'd take a yardstick and add 3 inches to it, and then take that and divide it into 1 billion pieces. We're talking very, very small. We're talking much smaller than we realize in some cases. The hair of a normal brunette, because that's the thickness they've measured, is someplace between 70 and 100,000 nanometers in diameter. So this gives you an idea of the scale with which we are working. If the distance between here and the moon was a meter, a nanometer would be about the length of my elbow to my fingertip.
Okay.
So as you can see, it's a small, small, small science. The whole concept behind the small science is that it increases greatly the surface area. Most everything takes place, most chemical reactions, most and things that are in your system take place at the surface of the molecule or the nutrient. And so what happens is that we reduce the size, and of course, because we reduce the size, we have more surface area. Principle, it's like chilling a drink. You can either chill a drink with a big ice cube, or you can take crushed ice and put it in, and the crushed ice works quicker because there's more surface area for the cold and heat to exchange.
Oh.
So we're talking that kind of process. Having said that, when we talk about our Hydrastat technology, we combine the nanoparticles with ultra-pure water and create a proprietary reaction that will take those molecules and protect them with molecules of water. So the big issue about nanotechnology is the nano pieces want to get back together. They want to agglomerate. You try to keep them separated as best you can. And there are a number of ways you can separate them. You can do it, the lipids we've talked about before, liposomes. A lot of people have done those. That's basically a fat cell. People will do mycelial coatings of some kind. And the coatings are such that they sometimes will be recognized by the cell and sometimes they won't. So having seen those kinds of things, what we do is we wrap our particles in basically a water cluster. And doing that protects it from reagglomerating it. It adds the ability to get it into the system because of its size, and it hydrates at the same time.
Oh.
So we've got all of these things going at the same time, and we've given that the label of Hydrastat, fast water.
Fast water, fast delivery.
Yeah, exactly, fast delivery.
Okay, makes perfect sense. Now, if we were to talk about delivery then, why, you mentioned ultra pure water. Can you take us down that path of ultra pure water?
Sure.
Number one, why do we need it? And then give us an idea of, like, for instance, hospital grade, IV grade, and then maybe computer chip grade.
Sure. When we start talking about ultra pure water, one of the reasons we have to start with ultra pure water is because of the impurities that are in the water. If you look at our tap water, and I don't care where you are in the world, there are like 90 acceptable substances in those waters. There is arsenic and lead and benzene and all these things. If you looked at the list, it would scare you to death. But what happens is that we are now going to work with very small particles. And if we don't start with ultra pure water, then we're nanosizing and emphasizing the particles that are already in the water as we bring it from the tap. So you got to start with ultra pure water. That's quite honestly, it's an off-the-shelf water purification process. We don't have anything magic there. And what happens is that it gets stripped of its contaminants. Everything disappears from what we would normally be drinking. Takes the taste out, by the way. Actually, don't ever drink ultra pure water. That's probably something you don't want to do, because it's looking to get completed, and it will complete your tongue and anything else. So we got to be a little careful with it. It's not like a caustic acid, but don't drink it.
Good to know.
That's your safety tip. That's one of your safety tips for tonight. So once we've got it purified, the purification of water is measured by the amount of energy it takes to complete a gap between two electrodes. Okay. And so I don't know if you remember back in the grade school, you'd put two electrodes in and then you'd squeeze a lemon, or you'd put salt in it, and suddenly that's because it makes it easier for that electric path to be completed because of the contaminants.
Got it.
And so as you take out the contaminants, in order to make that gap jump, you got to increase the energy that goes into it. And it's measured by mega ohms, and the theoretical high is 18.2, maybe 3 mega ohms in terms of purity, which means there is basically nothing there to complete the circuit in terms of contaminants in the water. Okay. Most IV solutions, most health solutions, are between 12 and 14 mega ohms. Pure water, it's been purified, sometimes distilled, but in most cases it's like 14, maybe the max would be like 14. So an IV that you get would be a 14 mega ohm water. The water that we use is someplace between 17 and 18. We try to get as close to 17 and a half as we can. It's usually anywhere between 16 and 18, but we're hoping on the north side of 17. The time you see the most pure treatment is when somebody's making memory surfaces or computer parts, where they need to make sure there is absolutely no contaminant on the surface, or that would short circuit one of the chips or something like that. Okay. So that's where you see the most pure water. That's why we do it. We basically start with ultra pure water to keep the reaction clean, but also to keep us from magnifying the effect of all of these bad things in tap water.
Okay, so on that note though, traditionally circuit board manufacturers, et cetera, those guys are going for 18, right?
Yes.
And we said, I just looked at ours downstairs, we're at 17.6.
Well, that's a good number.
So we sit,
I'm happy.
Yeah, we sit between our 17 and 18, which is exactly where we like to be. Now, on that note, so water soluble, that goes into our water soluble piece a little bit.
It's a little different when you start talking about solubility. Okay. We all know that there are some things that will dissolve in water and some that won't. And the things that don't dissolve in water won't dissolve whether it's contaminated water or ultra pure water. It's the difference in the chemistry. Those things that don't have a polarity won't be dissolvable into water because it's a polar molecule.
Got it.
And so the long and short of it is that you've got a number of nutrients that are non-soluble. And so the best we do on that is that we go through the steps of breaking them down as far as we possibly can, as small as we possibly can, and then we wrap them with the water. What we would rather do, if we could, is to find those those ingredients that are water soluble,
Okay,
which means
got it.
that they are completely dissolvable in water, and you end up almost on a molecular basis. So you've got the same number of molecules of a salt, for instance, in the whole batch. So that's the difference in solubility and non-solubility. Fortunately, we can do both, but that's a big deal. That's a big deal. Those that are making liposomes, they have to try to figure out how to create the liposomal shell on a non-soluble issue. There's no polarity. There's nothing else to pull it together. So it does make a difference.
So it's harder for the body to then utilize.
Well, it
or
is.
maybe not harder.
It's harder to transport.
Okay, harder to transport.
It's harder to transport. It is, and that's what our whole process. When you say what makes us different than anybody else, it's the transportation. We are a delivery system that nobody else is doing, but I'm aware anyway.
But the fact is, the reactor that you built and you continue to play with it, why is that so important to the process?
It is designed specifically, and this is one of the wonderful things about our technology. It's designed specifically to use what we already have in nature and exploit it.
Okay.
And so it's a particular set of designs and particular, at points we introduce energy to it. We do a number of different things. And it is the design of that piece of equipment that makes our product.
Got it. Well, that makes it
Pure and
easier.
simple.
Yeah.
And sorry, folks, you will probably never see a picture of the reactor on purpose.
Yep. I was going to do Bert undercover and a fuzzy screen where behind it you can see the reactor. We may do it still and just leave a lot of mystique there. But so on that note, so we talk about glutathione.
Right.
And Bert and I have this funny joke because, again, we're at the office next to each other, so we poke our heads in. And, there's conversation about glorified water, and we say, boy, is it glorious. It is glorified water to the nth degree. But the fact is, glutathione, obviously one of the most fragile molecules to get through the stomach. Our process now allows us to bypass that whole step.
Right.
So why, in terms of glutathione and nano and all that good stuff?
Glutathione made up of three precursors, one of which is cysteine.
Okay.
And cysteine happens to have a sulfur molecule at the end of its little body.
Okay.
If you were to look at the molecule, that's not true. It's not at the end. It's almost the belly button, but just the same. It's a molecule of sulfur, and the bonds that hold that are somewhat fragile. And so generally why glutathione doesn't get through the system is because those bonds are broken. And so in turn, so is the glutathione. So the body is the one that usually makes glutathione. Again, I told you we were nanomachines. What we do is we take this product and this product and this product, nourishment, whatever it is. We ingest it, and we go through the steps of then creating what our body needs in terms of energy, in terms of glutathione, in terms of a number of different things. Well, that all depends on a healthy system. And if you don't have a healthy system, then the absorption and everything else just doesn't go. So that's one of the important things about being gentle with the glutathione. Okay. And we can do that because, again, we're not using extreme measures.
Right.
So that's part of the
swish.
That's part of the magic in all of this.
Now, so on that note as well, when we talk about the formula, you've talked a little bit about surface area. In the newsletter, there were certain comments made about, trying to do apple-to-apple comparison. I hope everybody has seen the newsletter. Bert wrote a brilliant piece just helping us understand in digestible amounts how the process works. But apples to apples is never apples to apples in supplementation.
Well, and particularly in nanotechnology.
Okay.
We've always said that more is better. That's what, all of us have done that.
Yeah.
If 1 teaspoon of this is good, I'll take 2. I'm a big person. I can take 3, whatever it might be. But the reality of it in this particular case, more isn't better.
Okay.
Well, my mom used to say that life was made up of a lot of little things. And that's what this is. We're made up of a lot of little things. So what happens is that you look at it and say, okay, we'll take 2 equal amounts of our product in terms of its efficacy and the standard micron-sized products that somebody else offers. And they'll say, oh, look, we've got X milligrams in ours, and you only have Y milligrams in yours, and so yours isn't as good as mine.
Okay.
Or worse, because of the numbers, they're saying, oh, you don't have anything in it. Your glorified water comment.
Right.
The reality is that you can't compare the two. It's in the newsletter I said it's the difference between trying to measure the miles per gallon on a Chevy and a Tesla.
Yeah.
They're 2 different processes, completely 2 different types of cars, and it really is a totally different plan in terms of what it gets done and how you get things compared. And part of the beauty and also part of the frustration for me on the nano side is a lot of these things can't be as readily measured as we'd like them to be. I'd love to be able to and we have some fairly expensive and sophisticated equipment down there. But when you look at what goes on and how it goes on and what happens with the whole thing, it's more like if I put an ice cube out on the parking lot in the summer in Salt Lake and step back into the air-conditioned room and I watch that ice cube melt, pretty sure I can tell anybody that it's hot outside. Or it wouldn't be melting.
Right.
So a lot of nano science is experiential.
Okay.
A good deal of it is experiential because they don't know how to measure it in some cases. We can measure it if we take it up to the university or to somebody that's got a very professional lab and spend $70, $80, maybe $100,000 for a single test. We can do some of the tests that we need to do here. And in that regard, we at least know what the trends, what the composites look like, and that side of things. So when you start saying, oh, mine has this and ours has this, it doesn't work. The only way to really get the feel for whether or not it's helpful to you is actually take the product.
Well, we sure appreciate Bert, because I'll tell you what, without him, we wouldn't be here, folks. You wouldn't have an incredible product. We wouldn't have all the things that are happening that we're seeing in all of the parts of the world where people are having those experiential feeling of this is doing something for me. I don't know exactly what sometimes, and I don't know, I get to see some things that come across my desk that are absolutely mind-blowing in terms of the way that our product is working for people. Bert, thank you for being on the call tonight. And thank you for everything you've developed so we can have it.
It's fun. It's fun for me. I'm having a ball. They say that you're not working a day when you're doing something you love, and I certainly love it. So,
well, everybody, as you can see, we have an incredible person at the helm here who has a knowledge that is beyond all of us.